is with this, or with this thing here. So I'm actually going to give you guys a couple minutes to work on this on your own. What I want you to do is to provide the balanced equation for the reaction shown below and determine if the reaction will occur or not. You'll notice that in the phrasing here, it says solid aluminum metal is mixed with aqueous copper 2 sulfate to produce. You have to determine. So you are expected now to predict the product, which means you have to make sure that you get your formulas correct and everything else matches up. Okay? So if you got questions, raise your hand, and I'll come around to you to try and help you out. So we have Al. Why do we have to specify the S? It's a solid. Okay? Is mixed with. What does is mixed with mean? Plus. Now what's the next thing say? Shoot. Sorry, I got to write this a little smaller. I want it on one line. Plus. Now we got copper 2 sulfate. So where do we start? Copper, I'll get our symbol, Cu, and then SO4. What we should do before we move any further, I would check charges. What's our charge on copper? How do you know it's plus 2? The Roman numeral specifies the charge. Charge on sulfate? Minus 2. How do you know that? You had it memorized. It's one of those ones you have to know. Okay? Do our charges balance?
Yes.
Yes, which means our formula is okay. Last thing that we need to specify, we have to specify that it's aqueous, so we can put in our little aqueous to specify that. What does the to produce mean? Gives us our reaction arrow. I'm trying to cram this in here, but it may not all fit. Okay? Now we have to predict our products. What type of reaction are we doing? Single replacement. In the process of doing a single replacement, we need to shuffle our metal ions. Okay? So we're going to end up with, as a product, aluminum next to sulfate, and that will still be aqueous, plus copper solid. Yes?
Why wouldn't it be Cu plus and then the rest of it? Because I've seen it done both ways.
So does the order matter in this case? No. Doesn't matter. We can do copper solid and then do the aluminum sulfate, or we could do the aluminum sulfate first. That order does not matter. The only thing that matters is that we've put aluminum with sulfate. That's in critical importance.
When does it matter? Because I noticed
It doesn't.
doing neutralization equations that
It doesn't. It does not matter. Okay.
That threw me for a loop when I got to doing those. It's like, wait a minute.
It doesn't.
When did they do that?
2 plus 1 and 1 plus 2.
Yeah, it's the same thing. Okay. So, can we start balancing our reaction? No, why not? We haven't checked our formula. Balance your formulas first. Okay, we did it on our reactant side, we now have to do it on our product side. What is the charge on sulfate? What is the charge on aluminum? Plus 3. How do you know it's plus 3? That's one of the ones you have to have memorized. Okay? Is our formula balanced? No. How do we balance it? We will need 3 sulfates and we will need 2 aluminums. Why do I include the parentheses?
To note that that the 3 applies to the sulfate only.
It applies to the sulfate, so everything within that. Okay. We also want to include the parentheses to make sure that we don't see aluminum 2SO43. Okay. Remember, that parenthesis is there to really accent the difference between those numbers. Now that we have our formula balanced, now we can go through to balance the equation. Okay, so where do we start balancing our equation? Doesn't matter really, just pick something.
Yeah.
Aluminum, how many aluminums do we have?
1,
How many aluminums do we have on the product side?
2.
Is that balanced?
No.
What do we need to do?
Put 2 in front of the aluminum.
We need to make that a 2. Why do we put it as a coefficient and not a subscript? Subscript changes the formula, changes the compound. The coefficient changes the amount. Okay? When we're balancing the reaction, we can only change the amount. We can't change the formulas. Okay? So our aluminums are now balanced. So what do? Not quite start over. We can move to copper. Okay? May just be because we have different opinions on what start over is. How many coppers do we have on the reactant side?
One.
How many coppers do we have on the product side?
One.
Are our coppers balanced?
Good to go.
Yes. So what do we do now?
Go to the SO4.
Sulfate, which now looks like a delta. Let's fix that. How many sulfates do we have?
One on the reactant.
One on the reactant side. Why is it not 4?
Because you don't have parentheses, it's a molecule.
The 4 applies to the oxygen within sulfate. Just like when we look at aluminum, the L is part of the name of aluminum. The 4 within sulfate is part of the name of sulfate. Okay? It does not imply an amount. How many sulfates do we have on the product side?
Got 3.
We've got 3. Does that balance? What do we need to do?
Put a coefficient, yep, there we go.
3 in front of our whole formula, which means we now have 3 sulfates. Okay? So when we look at this, we'd say, okay, now it's balanced. Now is when I would argue we'd say start over. So now we go all the way back up to our copper, or aluminum, sorry. Aluminum is what we started with. How many aluminums do we start with? How many do we end with? 2. That looks pretty good. How many coppers? 3 and
1.
how do we fix it?
Put a coefficient of 3 in front of the product.
We need a 3 in front of that copper.
Bingo.
How many sulfates? 3. How many sulfates? 3. What do we do now? Check it again. Okay? It's now fully balanced. We're okay to kind of move forward from that point. Okay? So there's our balancing question. If we're going to now ask our single replacement question, does this reaction occur? Okay? To determine if this reaction occurs, what do we have to do? So we'll go through and pull this in orange. Okay? We're going to, evaluate, from my perspective, the ions. So I'm going to look at my copper and my aluminum. And I will find those on my activity series, if I can find them. There's copper and aluminum. Which one's higher on the activity series? Which means what?
There is a reaction.
Aluminum wants to be an ion. That's what our activity series tells us. We now go back to our reaction. Where is aluminum an ion? On the product side. For aluminum to become an ion, we have to do the reaction. So what does that mean? There is a reaction. Okay? Yes, we do have a reaction occurring. Okay? Kind of makes sense? When would it not be a reaction? Okay, let me... Yeah, let's pick... Yeah, it'd be a different equation, so we're looking at different things. So let's take gold solid plus... Yeah, why not? Lithium chloride. I'm going to kill the phases in this because the phases aren't going to affect whether it's a reaction or not. And we'll end up with... And I'm also not going to... Oh, crap, I'll balance
So when
it.
do the phases affect whether it's a reaction or not?
It doesn't. Period.
Because I've been leaving the phases on.
Yeah, I would too. But I'm lazy, so...
Okay. Just wanted to
3,
make sure I was good doing it.
3. So we've got it now officially balanced, right? Yeah. So now, does the reaction occur? So the same question we want to go through and do is find where we have our ions, our metal ions. So we're looking at lithium ion and gold ion. So we go back to our table and identify gold and lithium. Which one's higher? Lithium. What does that mean? Lithium wants to be an ion. Now we go back to our equation. Where is lithium an ion? On the reactant side. Would we expect a reaction to occur? No. Lithium starts as an ion. It's going to stay as an ion because it wants to be an ion. Okay? So in this case, no reaction occurs because lithium doesn't want to become a metal. Okay? Other questions on that? Okay. Takes a little bit of practice getting used to. You have to remember you got to deal with balancing, kind of, and then you've got a separate question on evaluating if you got a reaction or not. And that is ultimately looking at the activity series and applying whatever rules or whatever interpretation you want to use. In this class so far, we've talked about my interpretation, looking at its desire to be an ion. Other people will look at different aspects or different phraseology, but it's ultimately the same conclusion. Okay? Uh-oh. Oh. Okay, sorry. Well, we're going to attempt to stop the reaction. Stop this.
On the test, if we don't write the phase in, if we have to write these out, will we get ding points for that?